AcePhysics.org, Math and Physics Tutoring with Dr. Hudis. This presentation will help answer the question, what is physics? To explain what physics is, I will begin by considering an example of what a person sees while standing above the beach, looking out onto the ocean. After exploring the observations of a non-physicist, we'll delve into how the lens of physics unveils a fresh perspective, enabling us to see nature in a different way. This example is inspired by Richard Feynman. Next, I will discuss the different branches of physics and what they study. The goal of physics is to understand and explain the fundamental principles, these are called the laws of physics, that govern the behavior of the physical world. What is physics? I grew up in Monterey, California. I spent about 17 years of my life there. I think it's slightly overrated. Monterey is famous for having beautiful beaches and an incredible climate. There's no question it does have beautiful beaches, and I've never been to anywhere else in the world where every single day of the year is 75 degrees and partly cloudy. This is the lone cypress tree. I used to pass this every day on my drive to school. These are some views of Pebble Beach. This is a beach near my high school. Imagine that you were standing on one of these rocks above the beach and you looked out. Let's try to describe what it is that you would see. If you were standing here overlooking the spectacular Pebble Beach, you would see a beautiful cream-colored sand beach. You would see rocks everywhere with a multitude of different colors, shapes, sizes, textures, and densities. On this particular day, you would see a full moon at dawn. The moon is bright and dominant in the background. You would see waves crashing on the shore, and as they break, you would see frothy white water. The reason for the white water is because as the wave breaks, air gets trapped between the water molecules. The trapped air forms bubbles, which rise to the surface and create a foamy appearance. You can see thousands, if not hundreds of thousands of colors. There would be sounds of sea creatures, birds, waves, and wind howling as it passes through the trees. Depending on the person who's observing, one might see sickness, disease, hunger, love, and perseverance. What would you see if you are looking at the beach from the vantage point of physics? Physics teaches us that the moon is a rock. Sand is in fact just a bunch of little rocks and forms when rocks break down from weathering and eroding over thousands and even millions of years. If you understand everything about rocks, then you understand the moon, you understand the sand, and you understand the rock you are standing on. Water waves are studied in physics and are described by the wave equation. They are a periodic disturbance of the ocean water by the wind. It turns out that sound is also a wave, created by a periodic disturbance in the ocean of air that we all live in. This ocean of air is called the atmosphere. And light is also a wave, albeit not a mechanical one. Light is a wave created by the periodic disturbance of an electric field. If you understand all about waves, then you understand the ocean waves, and you understand sound, and you understand properties of light. And if an earthquake suddenly struck, you would understand that as well. Earthquakes are seismic waves that occur in the Earth's crust. There are millions of colors, but in fact every color is made up of just 3 primary colors. When you look out and see all these colors, the reality is that you're only seeing varying combinations and mixtures of just 3 colors. Everything on Earth is made up of the same 3 particles, namely protons, electrons, and neutrons. When you look out and see all of the richness and complexity of the world, you are simply seeing varying combinations of only 3 particles. The electron is a lepton and has no internal structure, while protons and neutrons are hadrons, composed of 2 types of quarks, the up and down quark. The world we live in is dictated by a small number of rules and forces, acting in an infinite variety of combinations. Nature, with all of its complexity, richness, and beauty, is in fact the result of a relatively small number of things, a handful of fundamental laws that dictate how everything in the world behaves. The world around us is the result of an infinite number of combinations of the relatively few fundamental laws of physics. As of 2023, physics is limited. It can't explain consciousness, emotion, dark matter, the meaning of life, etc. However, the laws of physics, albeit incomplete, are a small set of fundamental rules and discoveries that correctly explain and properly predict a myriad of phenomena in our world. These are all of the branches of physics. Mechanics is the study of motion and forces on the macroscopic scale. Macroscopic means what you can see with your naked eye, not using a telescope or a microscope. Glasses probably are still macroscopic. Electromagnetism, it's also called electricity and magnetism, is the study of electric and magnetic fields and forces. It's also the study of light. Statistical mechanics is another branch of physics. This is a branch of physics that employs statistical methods to describe the collective behavior of a large number of particles. Statistical mechanics studies many particles and explains how the average behavior of those particles leads to macroscopic properties. Einstein's theory of relativity is the study of space, time, and gravity. Quantum mechanics is the study of atoms and subatomic particles. Particle physics, which comes from quantum field theory, QFT. Quantum field theory applies the laws of quantum mechanics to fields and explains the behavior of elementary particles and their interactions. Condensed matter physics is a branch of physics. It's a field of study that explores the emergent phenomenon arising from the collective interaction of atoms and molecules in a solid. Astronomy and astrophysics study space and everything that happens out there. I'm going to discuss briefly the laws for each one of the branches of physics. On this slide, we're going to talk about the laws of mechanics. Mechanics is the branch of physics that studies force and motion on the macroscopic scale. The laws of mechanics are Newton's 3 laws of motion. The first law is, in my opinion, the least important. And there's a second and the third law, net force equals ma. For every action, there's an equal and opposite reaction. That's Newton's third law. Newton's law of universal gravitation says all mass attracts all other mass. There's a law of conservation of momentum. This is really a consequence of Newton's second law, but it's still a law of physics. There's the law of conservation of energy. Energy can't be created or destroyed. Rotational motion is studied, but it does not involve new laws of physics. It's an emergent phenomenon. And then Lagrangian mechanics are the laws of least action. The kinetic energy minus the potential energy, the integral of the time integral of that has to be minimized. And that's a law of physics, and that leads to the Lagrangian equations of motion. The next branch of physics, in chronological order of how physics was discovered, is electromagnetism. The laws of electromagnetism are as follows. All of matter is made of atoms, and atoms are composed of 3 fundamental particles: electrons, protons, and neutrons. Electrons, protons, and neutrons have properties called mass and charge. Coulomb's law talks about the electric force. Gauss's law discusses the electric field, which is the electric force per charge. And this says that opposite charges attract and like charges repel. This only works in physics. Sometimes I've heard in dating, opposites attract. That's absolutely not true. Opposites attract restraining orders maybe, but they don't attract when it comes to dating. The Biot-Savart law and Ampere's law are related to the fact that moving charges create magnetic fields. The Lorentz force says if there's a moving charge in a magnetic field, it will feel a force. That force is given by QV cross B. Faraday's law says a changing magnetic flux creates an electric field. And finally, Maxwell's law, it's kind of written as Maxwell's equations, but it's Maxwell's law, is that oscillating charges create light. Light is an electromagnetic wave created from a charge oscillating back and forth. The laws of statistical mechanics are a little more abstract. I'm just going to read through them briefly. To really understand these, you probably need a concrete example in the back of your mind. One of the laws is the principle of equal a priori probabilities in an isolated system. This says that all accessible microstates are equally probable. If you have some container with gas and that container has a specified amount of energy, that energy can be distributed over all the particles in many different ways. And as long as the energy is constant, each one of those is a microstate of the system, and each one of those has an equal probability. Another law of statistical mechanics is the principle of maximum entropy. This states the state with the maximum entropy is the most probable. Entropy will always increase. Here are the laws of Einstein's theory of relativity. The speed of light is the same regardless of the reference frame. The speed of light is the speed limit of the universe. Nothing can travel faster than the speed of light. If you got close to the speed of light, the entire universe would shrink down to the size of a peanut or smaller. All time would stop. It would be very interesting. The laws of physics are the same in all inertial reference frames. This is actually another one of the laws of relativity. This says if you're in outer space and you're flying in a spaceship and the spaceship has no windows and you're inside the spaceship, there's no way that you can do any experiment to prove that you're moving or you're at rest. You're in the spaceship, you're going at constant speed. It's impossible to tell if you're moving at constant speed or if you're at rest. Time dilation says moving clocks appear to tick more slowly when observed by stationary observers compared to when observed by moving observers. Length contraction, objects moving relative to an observer appear shorter in the direction of motion as measured by the observer. And then relativistic mass energy says E equals mc squared. Energy and mass are the same thing. Energy is equal to mass times the square of the speed of light. And then when you get into general relativity, there's the curvature of space-time. Mass and energy cause curvature of space-time, and the curvature in turn determines the motion of objects. Now we'll discuss the laws of quantum mechanics. Modern physics, which encompasses quantum mechanics, relativity, quantum field theory, some parts of astrophysics and cosmology, the laws and the rules of these subjects become a little more confusing. They feel like they're less related to your everyday world, even though they're not. But you don't move at the speed of light, and you don't see what atoms see, and so that makes it a little more less intuitive to understand these. One of the main rules of quantum mechanics is the uncertainty principle. The uncertainty principle states that there is a fundamental limit to the precision with which certain pairs of physical properties such as position and momentum or energy and time can be simultaneously known. The more precisely one property is measured, the less precisely the other can be measured. So if you know the position of a particle exactly, then you don't know anything about its momentum. And if you know the position of a particle to within a certain limit, then you know the momentum to within a given limit based on the uncertainty principle. Maybe you can invoke this on a traffic stop. If the cop says you were going 75 miles an hour, you can ask where. And if he says it was next to that mile marker, you can say, well, if you saw where it was, then it's impossible you knew my speed. However, I don't think that's going to work to get you out of the ticket, especially since these laws only work for fundamental particles, not for cars. Another one of the laws of quantum mechanics is measurement and the wave function collapse. When a measurement is made on a quantum system, the wave function collapses into one of the possible states, corresponding to the measurement property. The act of measurement forces the system to take a definite value. This is also called the measurement problem of quantum mechanics. It's a law of quantum mechanics, but it's a law of quantum mechanics that physicists don't like, because in physics, you want things to be certain. You want to know which one of the states it's going to collapse into, not just that there's a probability that it's going to collapse into this one or this one or this one. That's why quantum mechanics is frustrating to many physicists. Condensed matter physics is another branch of physics, and it's also a branch of modern physics. It's relatively new, but it doesn't involve fundamental laws, in fact. It involves emergent phenomenon. So let me read this. Emergent phenomenon in physics refer to collective behaviors or properties that arise from the interaction of many individual components. These phenomena are not explicitly present at the microscopic level, but manifest in larger scales, where the collective behavior becomes apparent. Emergent phenomena can exhibit properties that are qualitatively different from those of the individual components. Some examples are superconductivity, ferromagnetism, the fractional quantum Hall effect, or phase transitions. The fractional quantum Hall effect, you're actually able to get fractions of an electron or fractions of a charge. And that can't happen if you have a single isolated charge, but if you have a charge in a 2D electron gas with a field on it, then you can get fractions of a charge. A way to think of this is like a mob mentality. When a whole bunch of people are in a group, they act different than they would if they were individual. If they weren't in the group. So if somebody is just sitting at their house, they might have different behavior than they're with a whole bunch of group at a soccer game cheering on their team. There's a different set of rules for how they behave. Astronomy, which covers astrophysics and cosmology, is the study of space and the expansion of the universe, black holes, and everything that's involved with that.